in the last lecture, we have started talking about a very important concept. We called it as the PostgreSQL database installation. So till now, we have done the installation of PostgreSQL database on premises, which is basically we have installed the PostgreSQL database installation on Windows also. We have done the installation of PostgreSQL on Linux operating system. Oracle Linux we have used. We have done the installation of PostgreSQL database by using the EC2 instance, where we installed the Ubuntu operating system, and then we completed that. We have also done the installation of PostgreSQL database on AWS RDS also. So all these things we have discussed in the last lecture. Today we are going to start with another concept, which is again very important. Okay, let us try to understand about this architecture. See, just like other databases, Oracle, just like other databases like Oracle or other databases, PostgreSQL also follow the client server architecture. Okay, consider an example that, okay, so if you see this diagram, there are three things you will see. One is basically your memory part. So this is the part where you see, right, this is my memory part. So in my memory part, you can see multiple components are available related to the memory. Then we have the background processes. So this is my memory part where my processing part will be taken care. This is my background processes, and this is my storage part where my database related files are going to be stored. So whenever you see this architecture, in every architecture you will see these three components will be there. Now what will happen behind the scene? Okay, consider an example that there is a client, okay, he want to connect to the PostgreSQL database. So remember always one thing, that PostgreSQL is working like, for example, let's say you have installed the PostgreSQL server. So it is going to create your PostgreSQL instance. It is going to create your PostgreSQL instance, and this PostgreSQL instance is attached with the multiple databases. So we have multiple database like DB1, DB2, DB3, and by default some of the PostgreSQL database will be getting created. Like among that, the one is Postgres is also one of the database. Likewise we have template 0 and template 1 also. We have seen one more extra database, AWS admin, in the AWS RDS also. So basically we have a single instance which is connected with the multiple databases. Now whenever user want to connect to the database, let's say he want to access the object of DB1, the user will be always getting connected to the database instance only. The user will be getting connected to the database instance only. So basically database instance is having a lot of dependency over here. If you stop this database instance, for example, just take an example that you stop a database instance, then corresponding to their databases, everything will be stopped. When you say that I want to stop the instance, normally you are going to use a command like pg_ctl start and -d and your pg data location. When you run this command, your database instance will be stopped, and under this database instance, whatever databases are there, everything will be getting stopped. So if I want to show this diagram, so it can be like this also. Let's take an example. I have installed the PostgreSQL. So your PostgreSQL server, which has the database instance. Okay, this is my database instance, and which contain my multiple database like DB1, DB2 and DB3. If I stop this particular instance, so everything will be stopped. All the databases will be stopped. So basically the instance level is very important over here. If you are saying that can we stop one databases, like in Oracle we stop one pluggable database, that is not possible over here. If you stop the instance, it will stop your all the databases. So if you see this, the above diagram, consider a situation that there is a client, he want to connect to the database. So let's take an example that he want to connect to one database with the name DB1. Whenever you start your PostgreSQL server, whenever you fire the command like pg_ctl start the first process which will be getting started, we called it as a postmaster. So this is the main process. In PostgreSQL database, the main process is postmaster only. This is the main process, or we called it as a parent process. And this parent process will create a multiple backend process, that multiple backend process we called it as a Postgres here. So if you see here, we have a main process which is running, we called it as a postmaster. So whenever you are going to say that, or whenever you say that I'm going to start my server, the main process will be your postmaster. So postmaster is the main process, which is a parent process, and this parent process will create a multiple Postgres process, which is your backend process. So how many backend process? The number of backend process is completely depending upon the number of connections. So here how PostgreSQL will work internally, for every user, let's say there is a user 1, user 2. So for every user internally, one backend process will be getting created. So backend process number 1 and backend process number 2. The n number of users will have n number of backend process. So what is the purpose of this postmaster? This postmaster is a process, it's a background process who is responsible to receive a new connections. He is responsible to receive new connections. Like if I want to compare it with the Oracle, in Oracle database, your listener play an important role here, right? So we don't have listener here. The listener role will be taken care by the postmaster here. So whenever user is saying that I want to take a connection, I want to connect, when user is saying that I want to connect to the DB1 database or database, so postmaster is responsible to take a connection request, and then that request will go to the database. But before that, there are some authentication is also there. Host based authentication will be there by using a file called pg_hba.conf file, which I will explain you later. So there is a client. Now this client, he want to connect to the database maybe by using pgadmin, like pgadmin we use like in the last lecture. So there is a process, there is a client, he want to connect to the database. So that request will go to the postmaster. Postmaster will create a backend process with the name Postgres here. Now this is a memory part. Okay. In this memory part, we have a multiple memories are there. Like we have shared buffer, wall buffer, work memory, maintenance work memory. These are the 4 important component I have mentioned here. So why we allocate the memory to the database? First of all, why we allocate the memory to the database? See, whenever you are going to purchase a laptop or you are going to purchase a server, you will find a server with multiple component. A server will have a storage. I know that in the storage you are going to store your data. Let's say I want to store my video, audio, I need a storage. But if I want to do the processing, like you are starting this Zoom application. Now this Zoom application is running. So this is basically processing. So processing will be taken care, the processing part will be taken care by the RAM. And that is the reason, if you have more RAM, RAM we called it as a memory also. In database world, we called it as a memory also. More memory, more performance. So every database instance, so we are going to allocate, remember, when I say that I am going to allocate a memory, you are going to allocate a memory on instance level. So if this diagram, let's say to this database instance, I have allocate a memory called, let's say 40 GB. So this 40 GB of memory will be used by the DB1, DB2, DB3 and DB4 databases. We are not allocating the memory on database level. We are allocating the memory on cluster level. I would say cluster level. Cluster means the same memory will be utilized. So everyone by collectively they will utilize the 40 GB of memory here. And that is the reason we are allocating the memory. So let's take an example. There is a user 1. Okay. So what are the different memories are there? Let's try to understand about that. So there is a first memory which is mentioned here, we called it as a shared buffer. So remember this, we have shared buffer, we have background writer, we called it as a BG writer, and we have data files over here. So what I will do, I will just draw this here. I'll go here. Okay, so I have a shared buffer here. I have shared buffer. Okay, then we have a background process, we called it as a BG writer, and finally we have here multiple data files are there. Data files, we can have multiple data files, we can have multiple data files here. Okay, so this shared buffer is the part of your memory and this is a part of your storage. So this is basically your hard disk part. Okay, now what is the purpose of shared buffer? Consider an example that there is a user one, he want to connect to the database. Okay, he want to connect to the database instance, so he raised the request. That request will be taken care by Postmaster. Okay, and then let's say he got connected to the database. So what will happen, he is going to run the command like select star from emp. Okay, let's say he is saying that I want to select the data from the employee table. So those people who are coming from Oracle background, they know that in the Oracle database, or basically in every database, whenever you are going to run the command like select star from emp, this is the command which is not understood by the PostgreSQL database, because this is a plain English language only. So whenever you are going to run the command, first of all the SQL parsing will happen. SQL parsing will happen. So what is meant by SQL parsing? So SQL parsing means whenever you are going to run the command, first of all your syntax check will happen, whether syntactically, first of all your syntax check will happen whether syntactically this query is correct or not. Then let's assume a situation that okay, syntactically you are correct because you have written the correct statement. Then semantic check will happen. Semantic check means the person who is writing down the command, whether he is having, the person who is writing down the command, whether he is having permissions or not. So whether he is having correct permissions or not, whether the table exists or not, all those semantic check will be happen here. And then finally, then once you get like okay, syntactically the query is good, semantically, then optimizer is going to create your execution plan. Okay, so this is something we called it as SQL parsing. Then your optimizer is going to create execution plan. So what is meant by execution plan? The execution plan means the way when you run any command, when you say that I'm going to execute SQL query, when you say that I'm going to execute SQL query, so basically the optimizer is going to create an execution plan, and in that plan the query will be getting executed. So he will choose the best plan. If you remember in Oracle database architecture, if you have any plan, like let's take an example, if you are running the query for the first time, every time the new plan will be getting created, the plan will be getting created. But if you are running the same query next time, and if the plan is already exist, where that plan is exist in the Oracle, that's stored in the library cache. In PostgreSQL database, we don't have a concept called library cache here. So basically in PostgreSQL database, we don't have any area which will store your past plan. If you think that I already have a plan, why to create a new plan? So that area, it is not there. Here, when you run the query, every time the new plan will be getting created. Every time the new plan will be getting created, because we don't have any library cache concept here in the PostgreSQL database compared to the Oracle database. But the parsing will happen definitely. So whenever you are going to run any SQL query, the SQL parsing will be happen. In SQL parsing, basically your syntax check will happen, your semantic check will happen. It will check whether the table exists or not, whether the permission is there or not. The optimizer is going to create an execution plan, but this plan is only available for this plan is only available till this particular session only. Once the session is closed, and if new user is coming, again new backend process will be getting created and your old plan is gone. Every time it is going to create a new plan. Every time it is going to create new plan. Till now, whatever we discuss, is it clear, everyone? Till now, everyone, whatever we discuss, is it clear?
Please repeat the execution.
Okay. Now, the next part. Okay, next part. So, okay, let's take an example. There is a user. Let's take an example. There is a user. Okay. Let's take an example. In Oracle plans to store in Oracle database, we store the existing plan in where we stored that. Do you remember, guys? I have that Oracle architecture also. Oracle people, I have this architecture. See, if you see this
Library cache.
in library cache. So this is my Oracle architecture. So in shared pool, we have a concept called library cache. In this library cache, your existing plan will be getting stored, right? But in Oracle database, in PostgreSQL database, we don't have a concept called library cache here. Okay, that's what I'm saying. Now the next part. Now the remaining concept. So here. Now let's say the user is saying that I want to select a data from employee table. I have already done the syntax check, semantic check. I have a based execution plan. Everything is done. Who created the execution plan? The optimizer has created the execution plan. So whenever user is firing a command like I want to select a data from employee table, first of all, it will try to check the data whether it is available in the shared buffer, because it is a part of your memory, and memory is much faster compared to your storage. That is the reason whenever you are going to fire a command like select star from emp, I want to select the data from the employee table, it will check whether that data means in Oracle we call it as a block, here we call it as a pages, whether those corresponding pages are available in the shared buffer area or not. Shared buffer is very small actually. If the data is not available in the memory, because anything which is available in the memory is not permanent. If you restart the instance, all the data which is available in the shared buffer is gone. So if the data is not available in the shared buffer area, which is available in the memory, then it will take the data from where? Then it will take the data from data files. Who is responsible? Because data file is a permanent storage. Here in PostgreSQL database, every table have their corresponding data file. One table can have one data file or multiple data files also. So here in PostgreSQL database, the architecture is little different. One table, which is my employee table, can store their data into the one data file. So one table, one data file. But if the table size is very huge, then you can have multiple data file also. But one table, one data file concept is there. So whenever you are saying that I want to select a data from employee table, first of all, it will check the data into the shared buffer area. If the data is not available in the shared buffer area, then it will take the data from the storage. Storage definitely have a data because it is a permanent. Then that data will be copied to where? In the shared buffer area. And then finally, the data will be visible. The data will be visible to the customer or client side. It will be visible. So in PostgreSQL database, what is that background process who is responsible to copy a data from data files to shared buffer area if the data is not available in shared buffer area? What do you think, guys? There should be some background process, right? There should be some background process who is responsible to copy your data from data files to shared buffer area. Who will do that?
Server.
That is server process.
Background, right?
That is something we called it as a It's not a background writer, it's a server process, or we called it as a backend process only, backend process. And in Oracle database, what is that process we called? Server process. So I told you, right, every user will have one backend process. Every user will have one backend process. So that backend process will copy your data from data files to shared buffer area. Now if the user 2 is coming with the same request, where he will get the data? He will get the data into the shared buffer area only. So who is faster? U1 is faster or U2 is faster? U2 will get the data very quickly compared to the U1. So what is the purpose of shared buffer area? What is the purpose of shared buffer area? What do you think? What is the purpose of shared buffer area?
It stored recently used pages.
So basically your recently used data will be stored. Your recently used data will be stored under your shared buffer area. Okay. Okay. Now the next part. Now the next part. Okay. So when we are talking about the PostgreSQL architecture, the next component you see here, I'll talk about the background writer also. We call it as a wall buffer. Here you can see wall buffer. Then we have wall writer, which is a background process, and then we have wall files. Okay, let me draw here. So I'll draw everything here, scroll it down. Okay, so what we have here? So we have here shared buffer, then we have their corresponding data files. Okay, so we have data file here, we have data file here also. Then the next part, what is that background process? What is that buffer area? So whenever you see something, some terminologies like buffer, cache, okay, always remember that those are which are related to your memory only. So we have wall buffer here, and this is my wall files. My handwriting is not up to the mark, but somehow understanding na, whatever I'm writing down, just understand it. Now what is this shared buffer? We already discussed. Okay, now this wall buffer and wall files. Okay, this wall files we also called it as a transaction logs. Okay, what we called it as a transaction logs. So what is this basically? Okay, what is this? So whenever there is a user one, consider a situation that there is a user one. Whenever the users are performing any operations like DML operations or DDL operations, whenever the users are performing any DML operations or DDL operation, the corresponding transaction, first of all, it will be recorded into the wall buffer only. Or if I want to tell you in a very layman word, whenever users are firing any SQL query, that SQL query only, query, I'm not talking about data, okay, data will come into the data file. That SQL query or corresponding transactions will be recorded into the wall buffer. If you compare this wall buffer with the Oracle, this is something we call it as a redo log buffer, right? In Oracle database, we have a redo log buffer is there, na? Similar way, we have a wall buffer is here. So consider that I have one employee table, and in that employee table I have like ID, name and salary. So we have ID like 1, the name is Sagar and his salary is 1000. This is my current table. Now consider a situation that, okay, we have ID, name and Sagar. Let's take an example that you update the salary from 1000 to 2000. So basically that page you have blocked, that page you have changed. Basically how you change from 1000 to 2000? By running the command like update statement. So you fire the command like update table name set salary is equals to how much? 2000, where id is equals to 1. So you run this command, but you have not done any commit or you have not done any rollback. So what will happen behind the scene? Whenever you are going to write down the update statement, first of all, that transaction will be recorded into the wall buffer, which is a part of your memory. What will be written here? There is a person called 1. His old salary is, let's say, 1000, and his new salary is 2000. So this transaction has been recorded into the wall buffer. Now, as soon as every after 200 millisecond, whether you have done commit or you have not done the commit, what will happen? As soon as the 200 millisecond is done, the wall buffer changes, like, because it is a part of memory and storing anything into the memory is very risky. So what PostgreSQL will do internally, every after 200 millisecond, the transactions from wall buffer will be written to the wall files. How? It will be like 1, 1000, 2000, so that this transaction will be safely written into the storage area, which is my part of permanent storage. This is a permanent storage, this is a just a temporary storage. When it will happen? So the transactions from your wall buffer will be written to the wall files. The transactions from your wall buffer will be written to the wall files every after 200 millisecond. Who will do that? In Oracle, that is done by the log writer process, and here it is done by which process?
Wall writer.
There is a process called wall writer. So wall writer is responsible to write down the changes, whether it is a committed transactions or uncommitted transactions. Everything will be recorded from wall buffer to wall files by the background process called wall writer. But what will happen to the data file, right? My data file is containing 1000. My data file is containing 1000 as a salary. Now, since you are processing this particular page will be written to the shared buffer area. So this 1000 will be coming here for processing purpose, and you change this 1000 to 2000. This block, actually here we call it as a page. This block has been changed from 1000 to 2000. The block has been changed from 1000 to 2000. What is that block we called? What is that block we called? The block which has been changed into the memory. You change the salary,
dirty block.
We called it as a dirty block. The block has been dirty. We call it as a dirty block. So you have some buffer area which is dirty now. You have some buffer area which is dirty now. Now what will happen? There is a background process. Now you got some dirty area na? As soon as you have done commit or you have not done commit, before commit also, from dirty blocks will be written to data files, because he need to remove this buffer area. I don't want to make it 100% full. So what will happen? Every after 200 millisecond, here also 200 millisecond, every after 200 millisecond, the dirty block will be written from shared buffer area to the data files by the background process called, what is that background process? Here it is. There is a DB writer here in Oracle DB writer. Who is responsible here? Here in this case,
Background writer.
We called it as a BG writer or background writer. BG writer. Background writer is responsible when every after 200 millisecond. And there are other conditions are also there. Something we call it as a checkpoint and all. Whenever the checkpoint will occur, that time also the dirty blocks will be written from here to here. Even when the checkpoint will occur, from here to here it will come. Whenever the lock switch will happen, now some people might be talking about what is lock switch and all. We'll discuss about that. As of now, just consider an example that the BG writer and wall writer will be called every after 200 millisecond. Wall writer is responsible to write down your data or your transactions logs from your wall buffer to wall files, and dirty blocks will be written by the BG writer every after 200 milliseconds. Every after 200 milliseconds. And if you do the commit, the same block will not be updated. Just like a Oracle database. Here it will insert one more record actually. Here it will insert, as of now, just keep it in your mind that in Oracle, generally what happened, the same record will be updated to 1000 to 2000. In PostgreSQL internally, what will happen, if you have a record like ID, name and salary, and let's say your ID is 1, the name is, let's say, Sagar, and salary is 1000, you change this salary from 1000 to 2000, then again new record will be inserted here, Sagar, and the new salary will be 2000 on database level. So basically your table contained your old tuple means basically your record, and your this one will be also available, new tuple will be available, but this old tuple will not be visible to the end user. You will only see the new tuple, but actually in the table level, new record is also available, old record is also available. In Oracle, we also discuss about a concept called undo. In Oracle database, we called it as a undo segments, right? Do we have undo concept in PostgreSQL database? If not, how it manage? What was the role of undo table space, undo segment and all? What was the role of, guys, in Oracle?
It is having rollback segment which store the original value before doing any changes.
For read consistency purpose, or let's say, let's take an example. He want to do the rollback, correct? So that time this undo was playing an important role. Here in PostgreSQL database, we do not have a concept called undo. Here in PostgreSQL database, we do not have a concept called undo. And as I said earlier, PostgreSQL database internally use a concept called MVCC, multi-version concurrency control. I will not discuss about that as of now, but just keep it in your mind that in data file level, you know what will happen. So data file contain your old record also and new record also. Old record also, new record also. But this old record we called it as a data tuple, because those record has been changed and we got the new record. So internally, whenever you are going to update something, internally it is going to insert a new record. It is not updating the same record, and that feature we called it as a MVCC, multi-version concurrency control. Understanding, everyone? We'll discuss a lot of things about the MVCC, but as of now, did you understand the importance, like how this shared buffer, wall files and everything till now? Able to understand, everyone? Please let me know in the comment section, chat option, whatever it is. Okay, looks good. Everyone is saying yes. Nice. Okay. Now, when we talked about the memory, okay, obviously we want to increase the memory, we want to decrease the memory. So all those things are definitely possible. All those things are definitely possible in the PostgreSQL database. How to change the memory, where the memory gets stored, what is the configuration file, right? We will discuss that practically one by one. We are going to see about that one also. Okay, don't worry about that. We'll see that. Now, when we see this, yeah, definitely. If my table containing my old tuple as well as new table, definitely my size of my table will get increased, and my table contain a lot of unnecessary data because it has old tuple also, so it is unnecessary data. So we need to remove those old tuple or dead tuple. We need to remove that, and that can be removed by the background process. You can see, okay, not in this diagram. So that can be removed with the maintenance work memory. So there is a memory which is allocated, we call it as a maintenance work memory. That is something we call it as a maintenance work memory, and for that we need to call activity called vacuuming. Okay, so vacuuming we are going to understand about that, but before that let's try to understand about the work memory. So what is mean by work memory? Okay, are we allocating the work memory on instance level, or is it on user level or database level? What is mean by work memory? What are the scenarios where work memory play an important role? Anyone, any idea? Work memory, why we use this component we are talking about now. Okay, every component we can customize. Okay, every component we can customize, so don't worry about that. So first of all, work memory is completely a separate memory from your shared buffer area. So any area which you allocate to the shared buffer, let's say you allocate some memory to the shared buffer or wall buffer. Apart from this, we are going to allocate a work memory which is a different part. So what is the purpose of work memory? What is the purpose of work memory? So the main purpose of work memory is to do your temporary operations. Like every user will create a backend process, and every backend process will have some internal memory. Okay, among that the memory we are talking about is basically your work memory. So what is this work memory? Consider there is a user one, he is firing the command like select star from table name, and with this select query he is doing some sort of temporary operations, like let's say he is doing order by. In order by, like we are doing ascending order or descending order. So let's say he has millions of record and he want to know the topmost salary, second topmost salary, third topmost salary. So he is going to use order by salary. So this is basically your temporary operations. Whenever users are using any temporary operations like order by, or let's say he is using some aggregate functions like group by, or let's say you are doing some joining, these are all temporary, these are all SQL operation. It required your temporary area, because when you say that I want to order something, means I want to order it in ascending order or descending order, I want to join these two table. So basically you need some temporary area. That temporary area for that particular query, from where it will be allocated? From work memory. So every user, whatever query he is going to run, let's say there is a user, he is going to run the SQL query, which is a select query, and he is using order by or join or group by related operations. In that case, if it is required a temporary area to hold the SQL result, that result will be stored temporarily into the work memory. Temporarily, it is a part of memory, I'm saying. But this work memory is very small. Like for example, it is a 4 MB. For every SQL what is running, he will get the temporary area is 4 MB. You can increase it also. But if that memory is not sufficient to fit your temporary operations, then it will go to the storage level also, and that is something we call it as a disk level. So who is faster? Work memory is pretty much faster, and if it is going to the disk level, definitely the performance issues you will find, you will see the issues. So you need to check how much work memory you can allocate so that it will not go to the disk level. This work memory, remember what is meant by work memory in a very straight away answer. Work memory is a memory which is allocated to the user for the SQL queries to be executed, especially when he is performing the temporary operations like order by, group by, ascending, descending, joinings, hash join. So in that case it required a temporary area. That temporary result will be stored under the work memory. Where the work memory, shared buffer, all these parameters are defined. All those parameters are available into the configuration file. We call it as a PostgreSQL.conf. In this configuration file, that parameters are defined. In this parameter, that parameters are defined. If you want to increase the memory, you can decrease it, you can increase it, you can decrease it also. This work memory concept is also available with the Oracle database. Like in the Oracle database also, when users are performing any operations, that is also there. And what is that area we call, where the temporary area, we called it as in Oracle?
Program global area.
What is that?
Program global area. PGA.
It's a PGA. And if the PGA is not sufficient, then what it will use? What it is? PGA is also memory, which is a small memory. If the memory is not sufficient, then what it will use? Where that temporary operations will be performed? In Oracle?
Temp table space.
Temp table space. Then it will go into the temp table space. So temp file will be playing an important role. Here in PostgreSQL database, it will go into the work memory, and if the work memory is not available, then what will happen? Okay. If you have allocated the work memory, and if that work memory is not sufficient to hold your temporary operation, then what will happen?
It will go to storage.
Where it will go?
To the storage.
Where that temporary result will be written, right? What do you think? You guys
Well
are understanding my question?
Well buffers.
Hmm?
Well buffers.
No, wall buffer is something different. So it will go to the disk level only, and we can see that. Okay, it will go to the disk level only. Okay, and we can see that. Okay, we'll see that. I'll talk about that again practically when we see the performance kind of things. That time we'll see that. Okay, fine. Till now, whatever we discussed, is it clear? Whatever things we discussed till now, is it clear, everyone? Oh, looks good. Great. Right, everyone is understanding. Okay, we'll continue this PostgreSQL architecture, and we will try to go through the practicals also of your PostgreSQL. Okay, and slowly we will see the same examples on our AWS side also. Okay, thank you so much. Let's connect tomorrow. We'll continue this. Okay.
Sir, I have one question regarding installation.
Yes,
Sir,
tell me.
let's say in Oracle, in one server, we can install multiple Oracle homes binaries in different file system. In Postgres, do we have that chance? Like, let's say PostgreSQL 15 version, can we install only one, or
No.
like
You can
do we
install
have like
multiple.
in a,
You can install.
okay,
If you
that
want to
means like
install PostgreSQL 14 and 15, you can do that. There is no problem in that.
no, sir, only
Even
15,
if
sir.
you
Let's say I
even if
want.
you want to install PostgreSQL 15 also, there is no problem. You can do that.
Oh,
Okay.
okay,
It just like you need to change the data location. Okay.
okay,
Your PG data location, you need to change that. And if you fire like ps-ep Postgres, ps-ep pipe
okay,
grep Postgres, you will see the background process two times. But
okay,
one background set will be running from PostgreSQL 15 with this particular directory, and another set of background process will be running from another PostgreSQL directory.
okay. And just like what is the best practices? Let's say if we install that Postgres binaries, Generally here by default it goes to the like user USR location, like kind of root file system. Let's say I wanted to install in like on premises or like somewhere in EC2
See,
instance.
your binaries will be there only. Okay.
Okay,
But
in
generally,
user.
people will change the data directory and vault directory. Okay.
Okay.
So,
Okay.
if like I think in my first lecture, I have shown like if you want to customize data directory and vault directory, you can do that.
Okay.
So if you say pg and hyphen init db was command was there, right, to initialize.
Yes. Yes,
So
sir.
in that we can add a argument like where you want to keep the vault directory and where you want to keep the data directory. So you can do
Oh,
that.
okay, sir.
Okay.
Sir, one question.
Yeah.
Regarding architecture, once
Hmm.
data is written onto the disk, okay, and data, one user updated something, okay, and that data is written onto the background data written onto the disk,
Hmm.
okay, but that data is not committed, okay, and after some time that user got disconnected. He left the operation. He not committed or not rolled back,
Hmm.
and another user come and executed same data. If that user also require the same data, then how it will get that result? Because that data is written onto the disk, new data. For example, 1000 to 2000.
So
That
you have updated from 1000 to 2000, but have
correct.
you done the commit?
Not perform any commit, and then I left the sessions.
Okay,
And
ठीक है.
meanwhile, new user come up
हाँ.
and try to get the data. Try to fetch that data. So he will get 1000 or 2000 because
1000 only.
but
1000. Unless and until you have not done the commit, okay,
hmm,
the user will always see the older data only.
because of that MVCC, because old record is also available.
Because see, there is a mechanism. Mechanism means unless and until the data is not committed, okay. Unless and until, just like in Oracle database, we like control file is aware about everything, right?
Yes.
So here we don't have a control file concept actually, okay.
Hmm.
But overall, the PostgreSQL architecture is designed in a such way that only the consistent data will be visible. Inconsistent data will not be visible. So even though you have not done the commit, okay, unless and until commit you are not doing, he will always see the older data only. Always see.
Okay. Okay.
The session log up, it's
Hmm.
gone. It's gone. Okay.
Okay.
Once you log up, it's gone. See, PostgreSQL, the main challenge with the PostgreSQL I see, like Oracle is very managed database. Like everything you are keeping into the metadata tables. You have control file is there. So that is here in PostgreSQL. Most of the operations will be available on disk level. Means disk level means I'm talking about the metadata information. Okay, here it is everything managing on disk level actually. There we have for everything we have small metadata tables are there, but it is here. But yeah, coming to your question, without going here and there, he will always see older data. Okay, even if the same user get disconnect and connect back now,
Mm-hmm.
still he will see the older data. Because the backend process when u1 got connected and he got the backend process, that backend process is only available till the time you are connected.
Okay.
As soon as you go back, as soon as you do exit, then that backend process is gone.
Okay. Understood.
Thanks.
Thank you.
Thank you.
Thank you.